Hello, algebra classes. We're going to be working on a lesson where we're not going to be just working with one quadratic equation, but a system of quadratic equations. So let's take a look at Guided Practice 1 and see what we are up to here. So we see two different equations. One actually happens to be linear, so we only see a y and an x. So we know that we're working with a linear equation here. We'll graph into a line. And then this is a quadratic equation. We see x squared. So we know that that would graph into a parabola. So our job is to find out what is the x and y value that works in both of these equations. And I've drawn a little diagram over here so we can look at the possibilities. Well, if we have a parabola and a line, it's possible that they never intersect, and it's possible we're going to find no solution to this system. Or it's possible that the parabola and the line will intersect at one point only, if that line just grazes that parabola, and that would mean that it would touch it at only one point. There would be one solution. There would be one x-y pair that would be the point of intersection that would solve the system. Or the final possibility would be that this line could intersect this parabola at 2 points, and there would be two solutions. So we're going to see which one of these possibilities it is by solving the system. We're going to use a similar method to when we were working with our linear systems, where we were using either graphing or substitution or elimination to solve our linear systems. So we're going to see which would be the best choice for this particular system. Well, we're noticing that both of the equations are equal to y. And so we have each equation solved for a variable. Since we only need one equation solved for a variable for substitution to generally be a good choice, we're going to say, well, this system definitely would be a good system solved by substitution. So what we're going to do is we're going to take this second equation that has y equal to 2x squared minus 3x minus 2, and we're going to take this part, the 2x squared minus 3x minus 2, and we're going to put it in place of this first y here, because it is the same thing as y. And then I'm going to rewrite this first equation. Instead of y, I'm putting 2x squared minus 3x minus 2. And then that's going to be equal to x plus 4. So I no longer have a y in my resulting equation, which means I can solve for x and then go back and find out what my y is. So what I'm going to do is I'm going to say, well, factoring might be a good choice here to solve this quadratic equation, so I'm going to get equal to 0. So I'll subtract x and subtract 4 on both sides. That'll give me 2x squared minus 4x minus 6 equals 0. And then I'm going to try factoring, and using my x method, I'm able to factor this quadratic trinomial into 2x plus 2 times x minus 3. And of course, I'm still equal to 0. And then I'm going to use the zero product property, set each of these factors equal to 0, and find out what my x values are. So subtracting 2 and then dividing both sides by 2 will give me x is negative 1. Over here on my x minus 3 equals 0 equation, I'll add 3 to both sides, giving me x equals 3. And so I have half my story done. I know what my x values are at the point of intersection. So what I just found out, it looks like I'm going to have this situation here where I have a line intersecting a parabola at 2 points. And so I have my x values for those 2 points. Now I need to go back and find the y values that correspond to these x values. I'm going to choose whichever equation up here in my original presentation of the problem, whichever one looks easier to work with at this point when I substitute x in to find y. And this looks like a simpler equation. So I'm going to take the x values I got, I'm going to substitute them in for this x, I'm going to figure out my two y values. So that's what I'm doing down here. I pulled that y equals x plus 4 equation down, so when x is negative 1, I'll put negative 1 in for x. I'm going to work out my y value, which is 3. Here, when x is 3, I'm going to plug in 3 for my x value here, and I'm going to find out that y is 7. So my two solutions will be negative 1, 3. That's one of my ordered pairs. And then the other ordered pair is 3, 7. So I have two ordered pairs that solve this system. And that will be the 2 points of intersection when the line crosses over that parabola at those 2 points. My second guided practice problem, which will be the last one we're going to look at today, it's going to be the same idea where we have a quadratic equation, so this would graph into a parabola, and then we have a linear equation. This would graph into a line, and we're going to see if we can find at least one xy pair that solves this system. There's either going to be no xy pairs that work. It's either going to be a parabola and a line that never intersect each other, or it will be a parabola and a line intersecting at one point only. We'd only get one xy pair if that were the case. or it could be a parabola with that line intersecting it at 2 points. If that's the case, we'll get two xy pairs that work. So just like the last problem, these both happen to be equal to y, so I'm going to use substitution again as my method. And I'm going to go ahead and take this x squared minus 6x plus 11, which happens to be equal to y, and I'm going to put it in place of this y. So I'm going to rewrite the second equation as x squared minus 6x plus 11 is equal to the second part here, x plus 1. And then I'm going to go ahead and subtract x and subtract 1 from both sides. I want to see if I can solve this quadratic equation by factoring, so I'll get equal to 0. I'll go ahead and use my x method and find out that yes, I can go ahead and factor this quadratic trinomial into the product of two binomials. X minus 5 times x minus 2 is equal to 0. Then I'll use my zero product property. I'll set each factor equal to 0, find out what my x values are that solve this equation, and x is both 5 or 2. Then I go back. Now that I have two x values, that will be the point of the x coordinates for the point of intersection. Go back and I'll pick the easiest looking equation up here to substitute my x values in to find out my y. And I'm going to pick this second equation. It looks far easier. All right, so I'm pulling that y equals x plus 1 equation down, and I'm going to put 5 in for x, and 5 plus 1 is 6, so y is 6. So when x is 5, y is 6. So one of my ordered pair solutions is 5, 6. And then when x is 2, I'm going to substitute that in for this x. And I'm going to find out my other y value. 2 plus 1 is 3. So when x is 2, y is 3. And there's my ordered pair solution. So there's 2 points where this line and this parabola intersect, and it will be at the points 5, 6, and 2, 3. Okay, so your problems will be similar to that in your homework that you'll be working with. And remember that what you are trying to figure out is when you're given a system of equations that includes one quadratic equation and one linear equation, and that's the only type of problem you will be asked to solve today. You're looking to see, is there no solution? Is there no xy pair that works because the parabola and the line never intersect? Or is there one xy pair that works? That would be a one solution problem where we have one point of intersection. Or is it the situation where your quadratic equation and your linear equation have two solutions because there's 2 points that they share in common? All right, so make sure you have these problems in your notes and continue on with the homework for 9.7, and we'll see you next time.